Now we are pleased to welcome Mr. Anirban Manna, Business and Operations Principal at Atomionics, Singapore, a company at the forefront of quantum sensing and subsurface exploration.
With a strong background in management and strategy, Mr. Manna leads global growth initiatives, driving innovation in geophysical technologies. His expertise lies in bringing deep tech and geophysics to shape the future of exploration.
Today he will speak on new advanced quantum sensors, offering insights into how quantum technologies are transforming subsurface imaging. Please join me in welcoming Mr. Anirban Manna on stage. So, stage is all yours.
Unlocking Earth's Hidden Treasures. I quite like that name because the Earth is indeed full of treasures. Treasures that have influenced humanity since we started using tools, and treasures that will continue to influence our future trajectory of growth. Unfortunately, I would say our needs have slightly changed since we first evolved on Earth, where we need a lot more resources right now. But it's just getting harder and harder to find these resources. Because globally, resource exploration is still based quite a bit on trial and error. And that's because of two fundamental challenges. The first is that we don't have access to high quality data. You need high resolution data to be able to capture all the information in the subsurface, and we know how complex the subsurface is. So with low resolution data sets, you can't imagine to capture the necessary information you need. And the paradoxical thing is that now that we have found the stuff that was closest to the surface, the easier to find deposits, we are having to go deeper and deeper. But when you go deep, you need to be able to understand and formalize your strategy based on data. And so a combination of these two factors means humanity isn't that great at finding these deposits quickly enough. Definitely not quickly enough to power the energy transition that we've been talking about. It takes us a really long time to find these deposits. And that's what we started to think about at Atomionics. What was the reason? Because we have made some crazy advancements as a civilization in the technology front. Then why have we not gotten better at finding these deposits? And that's because we feel that we were focusing on just one side of the problem, which is interpretation of data. And that's why we see a lot of AI work happening, which is extremely valuable. But I think the machine learning experts in the room would agree. Garbage in, garbage out. And that's why you need to fundamentally change the data that you're capturing. And that's why Atomionics has been building quantum sensors to completely change how we collect data. Covering large areas in high resolution, capturing all the geological information there is to be captured, and then applying an AI layer on top of it to make sense of it. Funnily enough, the technology isn't new. We have used quantum technology to measure gravity back in the 1990s. The challenge was taking it out into the field. Because everything works great when your room temperature is perfectly at 25 degrees and your humidity is controlled. But as soon as you go out into the field, everything breaks down. And so the engineering challenge that we had to solve was making sure it works in a dynamic environment. And so we built our own sensor in 2021. It was pretty large, weighed around 400 kg, Took quite a bit of manpower to move it, but we could take it out. And we did take it out to understand how the sensor operates in the real world. And what we learned was implemented in the second version of our sensor, and now the third version. Now the question might be, why gravity? Why not quantum magnetometry or something else? And that's because gravity is one of the fundamental forces in the universe that works at theoretically infinite distances. And that means that once you collect a data point, all of the information around your data point gets captured into it. The challenge is to then decouple the information that is being captured. But our vision for data acquisition is to get rid of choice for you guys. And that's a strange thing to say because, everybody likes choice. But we have been forced to choose between two suboptimal choices. You either cover a large area in low resolution or you cover a small area in high resolution. We are combining the best of both worlds by allowing you to capture large areas in high resolution to make sure that every single piece of information is captured in the data set. Then we come to the next stage of the problem. And that's where our AI modeling layer helps make sense of the information that you're collecting. We go from high resolution 2D Bouguer anomalies and run it through our AI algorithm to get a density inversion model. And then there is an AI characterization layer that makes sense of how the density distribution in space means in terms of geology. And here the key thing is the high resolution data that's going in. A couple of years ago, I was in Australia at a geotech conference, and there was a guy presenting a joint inversion technique where he was combining gravimetry and passive seismic, ambient noise tomography specifically. And it was an interesting result because he found that even when combining multiple data sets, as long as they are low in resolution, there is a massive amount of vertical uncertainty in your 3D models. Up to 100 meters or 100 meter spaced data. So if you have 100 meter uncertainty, vertical uncertainty in your 3D models, you can imagine how incorrect you will be and how expensive that mistake is going to be when you use that to determine your drill targets. And so what we are enabling is effectively continuous gravity capture. Discrete data points taken so quickly and so close to each other that they effectively look continuous. And the beauty of it is that this data that you're collecting can be used later in the future, however you wish. Because the goal is to identify drilling targets with Oreo, our AI model. And this works for everything from shallow subsurface to the deepest of geological features. Today, you might be interested in copper. Tomorrow, you might be interested in hydrogen. And you can use the same data for hydrogen. The only thing that we are, looking for is the density contrast. But this density contrast exists in a lot of different geological features. The challenge so far has been to not get enough resolution, spatial resolution, when you're comparing, when you're collecting discrete data points with classical sensors. Especially when we're looking for critical minerals, which tend to be very finicky to find. But our end vision is to create a large planet model of Earth. Now you guys might be aware of large language models from ChatGPT. Imagine the same for our planet, where you can pinpoint all kinds of resources. And we're working toward that vision. In 2023, we built our sensor to be installed in the back of a vehicle and driven around while it takes measurements. So now you don't have to get out of the vehicle, place the sensor on the ground to take measurements. Now, we're developing our airborne system, which is going to be commercialized next year. And from there on, the only way is up. Imagine thousands of these drones covering an entire continent and capturing high-resolution data. That is the future that we're working toward. And this is our starting point. Resource-rich countries around the world. We've already done deployments in Australia and the US. And India is fascinating. India has so much potential that we want to be here. We have already seen the value of resources in Australia. Australia is one of the richest countries in the world per capita because of these resources. Now, India's GDP has grown extremely rapidly over the last 10, 20 years. Imagine if we could unlock the resource potential of India. We went to Australia as our first survey. We operated in the oil and gas space and captured quantum gravimetry data for one of our clients. And this was an interesting one because the problem statement for these guys was that they had a depleting oil reservoir. And they had brownfield regions that they were planning to sell. We went in, we captured data, we gave them some information, and they decided not to sell. Our next survey was with Rio Tinto in the US. This was for a copper project. Now, Rio Tinto got interested in us because they had worked on this problem statement themselves, moving-based quantum gravimetry. And they understood how difficult of a problem statement it is. It did not work out for them, but they still wanted to keep in touch with the cutting edge of technology. And that's how we got involved. And the next step is that we have a golden opportunity in front of us. Now, India is amazing at adopting new technology. I remember I was in Singapore for my university, and I left for a year, came back during the holidays, and I could not recognize the level of change that had happened. Everyone was accepting QR code payments. And it was funny to see because even now, having been to Hong Kong and lived in Singapore, there's still a massive gap in how common digital payments are in India versus in supposedly developed countries. And so I think we can replicate that in the resource industry. We can leapfrog the global industry standards and ensure that we're not making the same mistakes that the global industry makes utilizing existing technology. We can define our own standard. And Atomionics believes that we can shape India's exploration industry, imaging the most complex of geological features, going to the most complex of environments by automating data acquisition, then creating a national database of all this information to attract the relevant investments, and situating India in the front of the global energy transition by being a resource hub. But of course, we don't do this together. Sorry, we don't do this ourselves, right? We need to do this together, is what I meant to say. And we want to work with you guys in reimagining resource exploration. Globally, in the mining space, there is a false positive rate in drilling for up to 90%. There are so many junior explorers in Australia who go bankrupt just drilling in the wrong place. We want to change the equation. We want to change the statistics by massively improving the accuracy of drills. And at the same time, you get another benefit. You don't have to worry about environmental damage as much, because you're reducing the unwanted drills, you have a lower impact on the environment, and you're using non-invasive technology. And all of this eventually leads to just finding these resources a lot quicker, because we need to do that. There is no other way of developing how fast we want to develop in the energy transition space. And we have some amazing people who believe in our vision and are powering this. An interesting investor of ours is, of course, Paspalis. These guys are a Northern Territory government-backed fund. And NT is interesting because it is also extremely underdeveloped in the mining space, underexplored. And so they want to bring in new technology to accelerate the resource industry there. Then, of course, there is also a lot of potential on the defense side when it comes to infrastructure mapping in the subsurface. But a couple of notable mentions who are not on this slide is one of the founding members of OpenAI. She invested in us, as well as another person who built Facebook's AI research team. Now, these guys have been monumental in defining the infrastructure in terms of how we should be thinking about when it comes to AI on top of geological data. Again, going back to the ChatGPT example, how it works is it predicts words one after the other to form sentences. Now, the analogous implementation of that on density inversion of gravity is that you're predicting density layer by layer. As you go down, you're predicting the next density. And so we implement these advanced techniques into our solution to make sure that what we're building is what the resource industry needs. And these are some of the places we're going to be going to in the next 6 or so months, all around the world in a bunch of different resource spaces. But of course, we also want to be operating in India. And so if you want to continue this discussion, if you think we can work together, connect with me on LinkedIn, and we can continue the conversation.